Alright, today's lesson is over numbers and quadratics. Our objectives will be to understand the types of numbers, to understand what a quadratic equation is, and to understand what a radical expression is. To accomplish these objectives, we first need to understand the vocabulary. First, we have a quadratic function. This is a function where squaring is the largest exponent. We also have the real numbers. These are all rational and irrational numbers. Irrational numbers are numbers that can't be written as a fraction. And a radical expression is an expression that contains a square root symbol when it is simplified. We will first start with the real numbers. The real number system can be broken into two sections. Irrational numbers and rational numbers. The rational numbers are what we typically deal with. These start with our most basic concept. Counting. And the counting numbers are just that. We count with them. 1, 2, 3, and so on. After the counting numbers, we add in an integral part to our number system, which is our whole numbers. All the whole numbers is 0 with our counting numbers. After the whole number system, we add in another important part, known as the integers. The integers include the counting numbers and the whole numbers, along with all the negative counting numbers. -1, -2, -3. After the integers, we are now to the overlapping idea of rational numbers. Rational numbers, in their essence, are defined by the fact that they can be written as a fraction. Some examples of this would be 5/3 or 2.4. This is a decimal, but it is a decimal that can be written as a fraction, 2 4/10. Then we have the irrational numbers. Irrational is derived from the fact that IR as a prefix means no or not, and then rational meaning fraction. So irrational numbers would be any number that cannot be turned into a decimal, or into a fraction, that is. These are decimals that go forever, and they never repeat, they never stop. Some examples of this would be the square root of 3, or the term pi. Now that we know what the number system is, we're going to take a closer look at quadratics and how these numbers are used within quadratics. A quadratic is any equation or function where squaring is the highest exponent. So some examples of quadratics. This right here is a quadratic. We will learn more about the form later, but this is in general form. The idea here is that our highest exponent is a 2, which we know as squaring. This is another form of a quadratic. This is known as vertex form. In this form, we can do a lot of things. This is what we have been using to solve our squaring problems, is vertex form. And we're now going to use that form to look into what a rational answer looks like and what an irrational answer looks like. This right here is a quadratic. Our largest exponent is a 2, which means we are squaring. Because of this, we can solve, and we know from past experience that we are going to get two answers, a negative and positive, when we square root. When these square roots come out perfect, we have rational answers. When they don't come out perfectly, and we get decimals that go forever, we have irrational answers. And therein lies the difference. So what we do is we leave the square root in the problem, and we call it a radical expression. This right here will come out to be rational. We add 3 to both sides. We divide by 2. We square root both sides. Now we have two possibilities, a positive 2 and a negative 2. So what I like to do is write this in two forms. One with the positive and one with the negative. When we finish solving these two problems, we end up with negative 3 equals x and positive 1 equals x. These are both rational answers because the radical came out perfectly. The square root of 4 is 2, which gives us both a positive and negative version. Let's see what happens when we don't get a perfect square root. This problem right here, when solved, will not give us a perfect square root. Therefore, if we used our calculators, we would get a decimal that would go forever. Instead of doing all that work, what we do instead is if it doesn't come out perfect, we just leave the radical or the square root in the problem, and we call it a radical expression. We add 3 to both sides. We divide by 2 on both sides. We square root both sides. This right here, the square root of 7, does not come out perfect. It will be a decimal that goes on forever, never repeats. Therefore, it is irrational. So what we do is we call this a radical expression. We're going to leave the square root in the problem. We're still going to get two answers because we're square rooting. We have a positive square root of 7, and we have a negative square root of 7. And what we do is we solve for x. Because these two do not both have a square root around them, we cannot add or subtract them. So all we get is a square root of 7 minus 1 equals x. On this side, we subtract 1 on both sides. Again, because they do not both have the square root symbol around them, we cannot add or subtract them. Think about our like terms knowledge. So we get negative square root of 7 minus 1 equals x. These two answers are called radical expressions, and they are solutions to quadratics that happen because we don't have perfect squares that we're square rooting all the time. There are only so many perfect squares in math. We can't get them every time. Alright, this has been the lesson on numbers and quadratics. If there is anything that you missed, make sure that you pause, go back, watch it again so that you can learn. Thank you.